going to continue our lessons in chapter 6, 6.7, neutralization. Last class we have learned about standard solution, the meaning of standard solution, and two ways to prepare standard solutions with their respective calculations. So today we are going to continue with neutralization. So actually neutralization, you have learned about neutralization in Form 2 science, right? You have learned this topic in your during your Form 2, right? Yes. Do you still remember what you have learned there?
Little bit sangat.
Tak ingat sangat.
A little bit.
A little bit. Okay. So we will see whether you still remember or not what we have learned in Form 2. Alright, so definition of, as usual, you have to know the definition of the terms. So neutralization, what is neutralization? So neutralization is a reaction. You must have the word reaction. So reaction must be between two things. So it is a reaction between an acid and an alkali. And the alkali can also be a base. Okay, can also be a base. Base is in solid form, usually in solid form. The alkali, solution. Because alkali need to be dissolved in water. Right, so neutralization is a reaction between acid and alkali. And what are the products? Okay, to produce these two products, salt and water only. Okay, only. So this salt and water that are produced, are neutral. That is why it is called neutralization reaction, because the product produced is neutral. Okay. So acid plus an alkali, we got salt and water, and both of them are neutral. So when both products are neutral, it means that the acid have no more acidity, and alkali have no more alkalinity, because they have formed two different products. They have formed salt and water, so they are now neutral. What are the things that make an acid an acid? What is the important particles in acid that make an acid dipanggil acid? Do you still remember? What are the particles in an acid that makes an acid? Okay, the clue is in the definition of acid. Can someone please tell me what is the particle?
Hydrogen.
Hydrogen? Come again?
Hydrogen ion.
Good. So hydrogen ion is what makes an acid an acid. If we don't have hydrogen ions, then they won't be called an acid. How about an alkali? What does make an alkali an alkali?
Hydroxide ion.
Good, hydroxide ion. So neutralization reaction is basically when all the hydrogen ion are reacted with all the hydroxide ion to form water. Okay, meaning no more alkali, no more base, no more acid, no more alkali. They have formed water, and water are neutral. That's why this reaction are called neutralization. So for example, the neutralization reaction between nitric acid with potassium hydroxide produce potassium nitrate solution, our salt, and water. Okay, and here is the chemical equation. So here, what should you know? One is the meaning of neutralization, and second one is how to write chemical equation. Okay, we have been through this before. So chemical equation. So how do we know the salt there? We just change the partner. This is H plus, this is OH minus. So those two will become water. How about the next one? Nitrate ion and potassium ion will then become potassium nitrate salt. Okay, so this is how you write down the chemical equation. You should have no problem in writing down chemical equation anymore. Okay, next one is ionic equation. Ionic equation for neutralization. Okay, the following shows how the ionic equation for neutralization reaction can be obtained. Okay, from the chemical equation, when we write down the ions in, we write down every ions that are present. Okay, so nitric acid consists of hydrogen ions and nitrate ions. Potassium hydroxide solution made up from potassium ion and hydroxide ion. Our salts are made up from potassium ion and nitrate ions. And water. Water is molecules. They are not made from ions. So they are molecules. They cannot be separated to ions. So what happened then? We will now cancel out the things that we can found dekat sebelah kiri dan sebelah kanan. Okay, we can find hydrogen ions on the left, but we cannot find hydrogen ions on the right. Tak ada hydrogen ion. We can find nitrate ion on the left, and we can also find nitrate ion on the right. So we cancel out nitrate ions. Potassium ion, we have here on the left. We also have potassium ion on the right. So we cancel out potassium ion. Hydroxide ion, we have hydroxide ion on the left, but we don't have any hydroxide ion on the right. So we let it there. And then kita tulis apa yang tinggal. We left with hydrogen ion. Hydrogen ion plus hydroxide ion will produce water. So this is ionic equation for neutralization. Always this one, sama je. Okay, even though you change the acid and alkali, the ionic equation for neutralization will always be the same. It will always be hydrogen plus hydroxide ion equal to water, because neutralization is always the reaction between hydrogen ions and hydroxide ions. Okay, why do we cancel out potassium and nitrate ion? Potassium ion and nitrate ion are considered as spectators ion that do not change in the reaction. Macam mana kita tahu they do not change? Dekat sebelah sini pun dia ions. Dekat sebelah sini pun dia ion. Before pun potassium ni masih ion. After pun potassium ni masih ions. So the state of particles are still the same before and after, walaupun pasangan mereka berbeza. They still are ion, so they are called spectators ion. So they do not change. That's why they are cancelled out in the equation to form our ionic equation. So we will get this ionic equation for neutralization. Always the same. Okay, although you change the acid and alkali. So in neutralization, the actual reaction that occurs only involve the combination of hydrogen ions from the acid and the hydroxide ion from the alkali to produce water molecule. So this is what neutralization sebenarnya. Inilah sebenarnya maksud neutralization. Okay, neutralization ni sebenarnya the hydrogen ions from the acid and the hydroxide ion from the alkali neutralize to become water. Boleh faham setakat sini? Can you understand?
Boleh. Boleh.
Alright, good. If you have,
Boleh.
thank you. If you have any question, please just ask away, okay?
Boleh.
Alright, so we will continue. Chemical equation, this is basic things, okay? I will quickly go through it with you. You should know how to write chemical equation for neutralization. And for neutralization, we know that the product is, what are the product for neutralization?
Salt and water.
Good, salt and water. So we write it down, siap-siap dekat sini. Salt and water. Okay. Next, kita
Salt
cuba.
and water.
Good. Next, kita cuba identify what are the ions. Okay, kita identify what are the ions. So the hydrogen ions and chloride ions. Here is barium ions and hydroxide ions. How do I know the charge? By memorization. Okay, you should memorize it by now. So next is our chemical equation for, a chemical formula for water is always H2O. So semua dah terus H2O. Our salt. Salt is basically beside hydrogen and hydroxide ion. So we just add those two. 2, 1, BaCl2. So this is our chemical equation for our salt. And then we have to check, is our equation balanced? We have 1 hydrogen, we got 2 hydrogen. We got 2 hydrogen here, 3 hydrogens on the left side. 2 oxygen on the left side, 1 oxygen on the left side. So we got, put it in front 2, so we have 4 hydrogen here. We add another 1 hydrogen here. So 2 hydrogen, 2 chloride, 2 chloride, 1 barium, 1 barium, 2 oxygen, 2 oxygen, 2 hydrogen here plus 2 hydrogen here is 4, 2 hydrogen plus 2 hydrogen is 4. So this is a balanced chemical equation. Next, the same one, kita we identify our ions. Okay, so H2O is from H plus and OH minus. So we just find the formula for our salt. 1, 2, K2SO4. So here is K2SO4. Let's check if it's balanced. We have 2 hydrogen, 1 hydrogen, so 3 hydrogen. Here we only have 2 hydrogen. It's not enough. We have 1 hydrogen, 1 oxygen, 1 oxygen as well. We have 1 sulfate, 2 potassium. So we just add 2 here in front of K. So 2 potassium, 2 potassium. Now we have 2 oxygen. How do we make this this oxygen become 2? We put 2 in front. So 2 oxygen. Hydrogen now we have 4. 2 and 2 also 4. So this is a balanced chemical equation. Next one. Nitrate ion and hydrogen ion. This one is sodium ion and hydroxide ion. Those two will become water. So NaNO3. The same charge, you just write it down. So our salt is NaNO3. Sodium nitrate. Is it balance. So we have one hydrogen, two hydrogen there, one oxygen there, one nitrate there, one sodium there. It's already balanced. So that is how you write down a chemical equation for neutralization reaction. Okay. Next one is the application of neutralization. This one you also have learned it during your Form 2 times. Okay, you have learned this one, so I will just go through very quickly with you guys some of the application of neutralization. So first one, the famous one, the bee stings and ant bites are acidic in nature. When you are stung by bee, okay, their sting is acidic. So what should you do? You can reduce your swelling and the reaction by put some baking powder to neutralize the acidic stung. Okay, so when they are neutralized, they will form salt and water. So you won't feel corrodes, tak rasa dah all the acid and alkali punya properties. Okay, because they are all is not acid nor alkali. They are not acid or alkali. They are covalent compound. Okay, all is not neither one. Okay. Next one is wasps. Okay, wasps sting are alkali in nature. So bila dia alkali, kita nak neutralizekan dia, kita guna acidic substance such as vinegar. Vinegar is a weak acid. We don't use strong acid. We don't use strong acid dekat badan kita because strong acid is very corrosive. Don't use strong acid. Okay. Next one, application of neutralization in medicine. Okay, selalunya dalam ubat gastrik. Anti-acid are used to neutralize the excess hydrochloric acid. Okay, orang yang selalunya ada gastrik, it is because their gastric juice are released, okay, making they feel pain because their stomach dah macam sama ada become thin ataupun ada luka kat situ menyebabkan they felt the hydrochloric acid. So how to reduce the effect of hydrochloric acid? They will consume anti-acid ataupun ubat gastrik. Okay, so the anti-acid is actually alkali. Anti-acid medicine contain base alkali such as aluminium hydroxide or sodium hydrogen carbonate, calcium carbonate or magnesium hydroxide. In this picture, it is a milk of magnesia ataupun magnesium hydroxide, one type of base alkali. Okay, that relieve gastric pain. Okay, because they neutralize the excessive hydrochloric acid that are released in the stomach. Okay. Through that, this one pun in agriculture, slaked lime, calcium hydroxide is alkaline, so it is used to treat acidic soil so that the soil becomes lebih subur untuk menanam tanaman ataupun lebih suitable for the plants that are going to be planted there. So dental health, toothpaste is actually contains base that neutralize lactic acid produced by bacteria in our mouth. So bila kita banyak makan, dalam mulut kita sebenarnya banyak bacteria, and bacteria also usually produce lactic acid. And acid, as we know, is corrosive. Lama kelamaan dia boleh corrode our teeth. That is why we protect our teeth by using toothpaste. Okay, because toothpaste has base yang boleh neutralize the lactic acid so that our tooth takkan corrodes. And then hair health, okay, weak alkali in shampoo neutralize acid on hair. Okay, hair kita selalunya berasid, selalunya kita akan gunakan shampoo that is weak alkali to neutralize our hair. This one pun, Application of neutralization, another one is neutralization reaction also apply in the production of fertilizer. Fertilizer is basically selalunya is a salt such as urea, potassium sulfate, okay, ammonium nitrate and others. Okay, potassium sulfate is salt, ammonium nitrate is also salt. Okay, for example, urea can be produced from the neutralization reaction between ammonia and carbon dioxide. Okay, so how about other salt? How can you produce potassium sulfate? Using what acid and what alkali? Can you guess what acid and what alkali that can produce potassium sulfate?
Potassium hydroxide.
Potassium hydroxide is acid or alkali?
Alkali.
Good. Potassium hydroxide and what?
Sulfuric acid.
Good. Sulfuric acid. Okay. How about ammonium nitrate? What is our alkali and what is our acid?
Nitric acid.
Okay, good. Nitric acid. How about our alkali?
Ammonium hydroxide.
Ammonium hydroxide can be used as well. Ammonium hydroxide or ammonia. Okay, because ammonia is basically senang lagi dijumpai daripada ammonium hydroxide because ammonium hydroxide susah untuk dihasilkan. Okay, sedikit susah untuk dihasilkan. They are not really miscible. Dia selalunya lebih banyak dalam form ammonia. But it is correct as well. So good. You can identify the acid and alkali used from our salt. Good. Next one is titration method. Okay, now we are going into experiment. Okay, titration method. So titration methods ni apa? So titration methods ni is usually titrate. You titrate something. Titrate is by using burette. So that's what. Okay, sekarang you have to familiarize yourself with this setup. Allah. You have to familiarize yourself with this setup. Okay, this is called titration. Titration ni apa? Titration is quantitative analysis untuk apa? To determine the volume of acid needed to completely neutralize an alkali ataupun vice versa. To determine the volume of alkali needed to completely neutralize a volume of acid. So, in this picture, we have our alkali there. And we want to know, and this is our acid. Inside the burette is our acid. Inside this conical flask, sorry, where is it? Okay, inside the conical flask, we have our alkali. So when we titrate, meaning we adding little by little acid. Okay, kita addkan a little by little acid into our alkali. Okay, and then we determine how much acid that are needed to neutralize this alkali. How do we know that the alkali is being neutralized? By adding some indicator. So when the indicator changes color, we know that it has been neutralized. And then we record the volume of acid needed. Itu basic titration methods tu apa? Kita add something sampai satu reaction dah complete and then we take the measurement, we take the volume. That is basically what titration method is. So acid-base titration meaning kita cuba titratekan acid with base. Acid with alkali and base. So acid-base titration usually are used to determine the concentration, bukan lagi volume sahaja. Okay, but dia nak cari lebih lagi daripada tu. Determine the concentration of acid or alkali using solution of known concentration. Okay, perkataan known concentration ni kita pernah jumpa before. It is a standard solution. So let's say Our standard solution is our acid. So we want to find the concentration of alkali. If our known solution is alkali, so we will find the concentration of
Acid.
acid. Good. Itulah sahaja penggunaan acid base titration. Selalunya digunakan untuk itu. Okay? To find concentration of alkali ataupun concentration of acid using standard solution of acid or alkali. Depends lah. Okay, if you use standard solution alkali, meaning you want to find concentration of acid. If you use standard solution of acid, you want to find the concentration of alkali. So based on this picture, what is our standard solution?
Nitric acid.
Good.
1.0 mole.
1.0 mole is the concentration. Our standard solution is nitric acid. Good. So this is our standard solution. So standard solution is nitric acid, is acid. So what is the concentration that we want to find? We want to find concentration of apa dalam ni?
Alkali.
Potassium
Alkali.
hydroxide.
And what is our alkali?
Potassium hydroxide.
Good. Potassium hydroxide is our alkali. So we want to find the concentration of our alkali there. So we use this setup. Good. So macam mana kita nak find the concentration? Okay, when we use titration, okay, we will get, we will find the volume. Okay, so from the volume, we calculate the concentration. Meaning, when we use this experiment, when we conduct this experiment, you can, your result is the volume. Okay, but how can you find concentration? You have to calculate from your result, from the volume that you got from the experiment. Using this formula, we will get through this formula next lesson. Okay, for now, we will take a look at the experiment first. Do you have any question here? Sekarang kat sini faham?
Paham.
Faham.
Okay, good.
Faham.
Alright, thank you. So, acid-base titration. So, acid-base titration ni, what should we do? Okay, we will use solution from known concentration. So, our standard solution lah. Okay, standard solution. Our standard solution must be in burette. Okay, our standard solution must be in burette. Okay, just like this one. 1.0 mole per dm cube of nitric acid. And then, our solution that we want to know the concentration, the unknown concentration, is put in a conical flask. So this is conical flask. So this is our unknown concentration. This is the known concentration in burette, unknown concentration in conical flask. And then you do the titration. Titration will stop at endpoint. Okay, this is another words that you need to know. Will stop at endpoint. Endpoint is when acid-base indicator change color. We usually put some indicator with our unknown in our conical flask. Okay, with our unknown concentration solution, and we will see when they change color. When the indicator changes color, it means that the reaction has complete. Okay, the solution inside here is already neutralized, and it is the endpoint, the stop of our titration reaction. So what is endpoint? So endpoint is actually where the amount of acid added ataupun amount of alkali added to our conical flask completely neutralize all of the alkali ataupun all of the acid. Okay, so that is what we call endpoint. Okay, so endpoint is also when all the hydrogen ion completely neutralize all the hydroxide ion and produce water molecules. Sama lah. Okay, neutralization. When all the hydrogen ions dah neutralize all the hydroxide ions to produce water molecules. And it is also where acid-base indicator changes color. Example of acid-base indicator that you should know by now is these two, phenolphthalein and methyl orange. And another one is universal indicator. You should know the color. You should know the color when it is acidic, when neutral, and when alkaline. And this is already learned during your Form 2. So you should memorize it by now. You should already know the color by now. Okay. So universal indicator, color of universal indicator when it is in acidic, it is red. When neutral, universal indicator turns green. And when alkaline, the universal indicator turns blue. You should know the color, and you should know the color of these three indicator when they are in acidic, base, neutral, and alkaline. You have to know. Okay. The famous one is phenolphthalein lah. But you should also know the color for methyl orange and universal indicator as well. Okay. Up to this point, any question?
No.
No.
Alright, next one. So we will now go through the procedure of acid-base titration. So as we know, acid-base titration, the aim is to determine the concentration. Okay, depends lah on our standard solution. Tadi kita dah identify the standard solution is acid. So we will find the concentration of alkali. So in this example, when we do our acid-base titration, we want to determine the concentration of potassium hydroxide solution, our alkali. Okay, that is our aim, to find the concentration. How do we find the concentration? By doing titration and by recording the volume dulu. Baru kita calculate untuk dapat titration. So two things lah, two steps. Our materials, okay, materials must be our standard solution. So when we write down standard solution, you have to write down the concentration as well. The known concentration, 1.0 mole per dm cube nitric acid. Our alkali, potassium hydroxide, that is the things that we want to know, the concentration. Phenolphthalein indicator, or your chosen indicator, you can write down methyl orange or universal indicator as well. And distilled water. That is our materials. Apparatus is burette. Oh. Where is it? Okay, good. Apparatus is burette. Okay, this is burette. Pipette. Do you still remember pipette? Why do we use pipette? Because pipette is more what?
Accurate.
Good. Accurate. Okay. This one, we don't know the concentration, but we have to know the volume. Okay, we have to know the volume. This one, we don't know the concentration. Terbalik dengan yang ni. Yang dalam burette, we know the concentration, but we don't know the volume needed. Allah. We don't know the volume needed. Terbalik. Okay, so that is why we use pipette. Pipette kita dah guna 25 cm cube pipette, so we know that this alkali is 25 cm cube. Okay, pipette filler 250 cm cube conical flask. Okay, this is our conical flask. White tile, retort stand. Okay, if you still remember, retort stand with clamp. That is all that we need for our acid-base titration. Next one, procedure. So first one, we need to rinse our pipette. Pipette tu kita gunakan, okay, saya cuba lukis sikit. Kita gunakan pipette, okay, ada pump dia, to transfer okay, from a beaker lah. So this is 25 cm cube pipette. We use to transfer it into a conical flask. So untuk transferkan our solution into the conical flask, okay, we use pipette. Okay, we don't measure 25 cm cube using measuring cylinder, no, because we want to get an accurate volume. So before we use our pipette, we rinse it first. Okay, and we rinse it with potassium hydroxide solution. We don't rinse it with water. Okay, kenapa? Sebab kita nak dapatkan potassium hydroxide je. Kita tak nak dia punya concentration dia berubah before we find the concentration. Okay, so kita bilas dulu our pipette. Okay, this is our pipette. Kita bilas dia dengan potassium hydroxide. Bilas. Okay, kemudian remove the solution. Okay, maksudnya dia dah dibilas dengan potassium hydroxide. Kemudian kita masukkan dia dekat dalam beaker containing potassium hydroxide dan kita pipette out. Kita bagi dia sampai calibration mark 25 cm cube. Kita transfer dekat dalam conical flask 25 cm cube. Next, we add a few drop of phenolphthalein indicator dalam conical flask. Add phenolphthalein ataupun methyl orange ataupun universal indicator and swirl the flask. Kemudian kita kacau-kacaukan sikit. Next, kita akan guna burette pula. Burette pun kita kena rinse dulu dengan benda yang kita nak masukkan dalam tu. So kita rinsekan burette dengan nitric acid. With 1.0 mol nitric acid and then kita remove solution tu. Kita rinsekan dulu, bilas dulu, kemudian baru kita fill the burette. So fill the burette with 1.0 mol per dm³ of nitric acid and clamp the burette onto the retort stand. Record the initial reading. Kita mesti record initial reading sebab kita nak dapatkan volume of the acid needed. So we have to find volume by minus final reading minus initial reading to get the volume. Where is it? To get the volume. And then we will drip. Okay, ni barulah bila kita dah bubuh acid dalam urette, dah bubuh alkali and indicator dalam conical flask, barulah kita drip. Kita dripkan our acid into our conical flask. Drip acid slowly into the conical flask while swirling it. Sambil awak kacau dia. Kacau perlahan-lahan. Okay, swirl. Dia macam pusing-pusingkan conical flask tu. Okay, bukan goncang, okay? Not shake. Swirl. Okay. After that, you will stop adding the nitric acid as soon as the color of solution in conical flask change from pink to colorless. Pink ni maksudnya dia alkali. Colorless maksudnya dia dah neutral. So bila dia dah warna colorless, so you stop adding more acid. You will then record the final burette reading. Okay, tadi kat atas ni, sekarang kat sini. Okay, record yang ni yang initial, yang final. Then you record. Where do you record it? In this rough table. Let's say initial reading tadi 50, final tadi 28 cm3. And then you calculate the rough volume. Okay, calculate lah berapa rough volume. Berapa rough volume of nitric acid needed? Can you calculate? How much?
22.
22, good. So the volume of 1.0 mol of per dm³ of nitric acid needed to neutralize our 25 cm³ of potassium hydroxide is 22 cm³. Okay, 22 cm cube. So you write it down at the rough. So now kita dah dapat rough reading. Okay. Next, what should you do? You will have to repeat steps 2 and 3. Okay, you have to repeat. Kita akan buanglah this solution and we will measure balik 25 cm cube of potassium hydroxide masuk balik dalam tu. Okay, and then sekarang ni kita akan buat balik. Ulang balik prosedur tu. We will now flow 1.0 mol per dm cube of nitric acid. Kita boleh buka laju-laju sikit. Okay, 28 tadi. Bukan, 22 tadi kan? Okay, minus 5. Berapa? 18. 17. Okay, awak pun flowkan je 17 cm cube of nitric acid ke dalam conical flask. Sebab apa awak boleh flow sampai 17? Sebab awak dah dapat rough reading tadi. Kita perlukan dalam 22 cm cube. So awak boleh add je dulu sampai 17. Okay. So bila dah add sampai 17, stop the flow. Kemudian add balik drop by drop. Bila dah sampai 17 cm cube, awak kena add drop by drop into the conical flask while swirling the flask. Awak buat lagi sekali lah eksperimen ni sebenarnya. Okay. Occasionally rinse the inner surface of conical flask with distilled water. Okay, dia kata kadang-kadang awak rinsekan tepi conical flask ni dengan distilled water. Why? To ensure all the nitric acid yang mungkin terpecik ke tepi, ke kiri, ke kanan distilled water conical flask ni semua masuk balik dekat dalam alkali. Semua berjumpa dengan alkali. Okay, to ensure all the nitric acid titrated into the potassium hydroxide solution. Kemudian bila awak stop the titration, bila the colour of the solution bertukar menjadi colourless. So awak dapat balik bacaan tadi. 28, 22. Let's say awak start yang pertama tadi, biuret awak dah dekat 28. So kemudian awak tinggal 5. So 28 tolak 5, 23. And then record the final. Okay, awak record balik 5. Record and then repeat balik 2 kali lagi. So repeat balik 2 kali lagi. So you will get 3 readings. Record your reading in table 6.4. Macam ni lah. Okay. Kemudian dah tinggal 5, awak isi balik biuret tadi 50. Isi balik conical flask. Buat balik titration sampai 17. Kemudian awak slowly add drop by drop. Awak dapat lagi 27. So tolak dapat 23. Kemudian lagi satu awak buat. Pasal ni. Awak buat lagi satu. 27. Bacaan. Saya tak boleh tulis kat situ lah. Bacaan yang ketiga. 27. Awak start. Kemudian awak end dekat 25. Awak end dekat 2. So 25. So ini adalah result awak. So this is your result. So macam mana, apa yang kita dapat daripada result is the volume of nitric acid. So when you have 3 readings, what should you do? You should find the average. So average nitric acid use is 23 plus 23 plus 25 divided by 3. 3 readings kan? So dapat berapa? .67 centimeter cube. This is our average. Okay? So itulah volume. So from this volume, we will have to calculate to find concentration. And this we will do in our next class. Okay? But until here, you should know how to do the experiment. Okay, you will also, okay, this is the link for the experiment. We will watch this experiment together. Kejap lagi nak jawab discussion sikit dulu. Why is a white tile is used? Kenapa kita guna white tile dekat bawah ni? Siapa boleh agak or answer this question? Kenapa ada white tile kat bawah ni?
Tengok colour.
Supaya dia lebih
Good.
selamat.
Supaya dia jelas.
Sorry? Again? Again, girl. Siapa tadi?
Ellie.
Yes.
Untuk tengok colour.
Untuk tengok colour, good. To observe our colour changes. Okay, because the colour change from pink to colourless. Okay, so bila awak ada white tile, it will be easier for you to determine pink tu semua dah hilang ke belum. Atau sebab kalau kita buat dekat atas permukaan, let's say our table is in black. Okay, so you will hardly see any pink. Bila pink tu dah dilute, awak tak nampak pink tu dilute. Awak ingat semua dah turn colourless. Padahal ada lagi warna pink. Let's say macam tu. That is why we use our white tile to observe colour changes accurately. Next, why should we not rinse the inside of conical flask with potassium hydroxide solution before beginning of the titration?
Supaya concentration dia tak berubah.
Supaya concentration dia tak berubah. Why should not we rinse? Why should not? With potassium hydroxide solution before beginning. Why should we rinse kot? Tak ada not kot. Kenapa kita rinse with potassium hydroxide? So that the concentration does not change, because we want to find the concentration. What is the operational definition of the endpoint? Okay, apa maksud endpoint tadi?
Indicator.
Endpoint bukan indicator. Endpoint adalah point di mana
Perubahan warna.
Perubahan. Acid has completely changed.
yes, acid bukan change. Acid has completely
Neutralized.
yes, neutralized. Okay, so endpoint dia punya general maksud adalah when acid is completely has completely neutralized the apa? Dia neutralizekan siapa?
The alkali.
Good. The alkali. So when they add the operational definition for this activity, meaning you have to be specific of our acid and alkali. So the answer should be when the nitric acid has completely neutralized the
Potassium hydroxide.
good potassium hydroxide. So that is the meaning of endpoint. Good job. So let's take a look of a video for this acid-base titration. Okay, kita tengok sama-sama. This is from MRSM channel YouTube. Okay, if you go into MRSM channel in YouTube, you will find that they have lots of experiment videos. Not only just in chemistry, we also have experiment video for biology and physics. Okay, so take a look at it. Okay, especially for the experiments yang awak tak dapat nak buat lagi, but the teachers have taught you. Macam yang saya bagi tadi, dilution methods tu, and how to prepare standard solution from solid, and how to prepare standard solution from standard solution lain, concentrated standard solution, semua ada dalam tu. You can have a look. So now kita akan tengok yang ni. After this video, we will end our class first. Okay, and you will have to do some exercise for these lessons. Your module, page 157 until 159, I've already put it in your Google Classroom under exercise 8. Okay, the due date is this Thursday. Okay, so we will see the process, and then our next class I will proceed with the calculation to find the concentration. Remember, kita buat eksperimen ni, the aim is to find the concentration, right? But after the experiment finish, we only got the volume. To find the concentration, we have to do some calculation, and those calculation we will learn it next class. Clear?
Clear.
Yeah.
Clear, good. So we will watch this video first, and then okay, this video is not there. Should watch it here. Alright, can you see? Can I have some response? Can you see my the screen changes now?
Yes.
Okay.
Yes,
Alright. Okay, jom kita tengok sekejap. Okay, this is activity. Ni dilution, sorry. The wrong one. Sorry, not this one. It is 6.7.2 neutralization, acid-base titration. Okay, this is our aim. Sama macam tadi, to determine the concentration. The same one. Okay, while we are at it, saya tunjuklah. This is our pipette, 25 cm cube. Ada tulis kat situ 25. This is our pipette filler. Kita akan guna pump ni untuk pastikan the solution masuk dalam pipette. This is our burette, white tiles, retort stand and clamp, conical flask, filter funnel, filter paper. I don't tiada guna kat situ, but they just put it there. Step 1, rinse. Okay. That is what they are doing. Dia tengah rinsekan our pipette. Guna the nitric acid. We want to make sure that there are no distilled water inside. Lepas tu baru kita pipettekan 25 cm cube. Okay. Make sure semua masuk until calibration mark. Barulah kita dapat 25 cm cube of nitric acid. Okay. There. Meniscus level. Okay, mesti dekat bawah tu baru dapat calibration mark. Okay, baru dapat accurate 25 cm cube of nitric acid. Kemudian kita transfer ke dalam conical flask. Okay, make sure everything is transferred. Then we add phenolphthalein, our indicator. Beberapa drop saja. The solution will change color into pink because our solution is now alkali. Oh sorry, this is not nitric acid, potassium hydroxide, sorry. So alkali is pink. Kemudian kita rinse burette pula with our nitric acid sebab kita nak bubuh nitric acid dalam tu. Okay, this is how we rinse our burette sampai ke bawah. And remove everything. Pastikan semua yang lain keluar. Kenapa dia ketuk-ketuk tu? To make sure everything is out. Tak ada yang tertinggal dalam tu. And then kita fillkan burette dan kita clampkan pada retort stand. So this is our acid. Okay, dia fillkan using filter funnel and glass rod supaya tak ada yang tertumpah. After we fill it, we record the initial reading of the burette. Dia buat apa ni? Dia cuba remove air bubble. Sebab tu dia buka dulu untuk pastikan. This is not conical flask. Dia tak bubuh dalam conical flask lagi. Dia bubuh dalam beaker dulu. Why? Untuk make sure that semua air bubble tak ada kat dalam ni. Kat dalam ni semuanya adalah nitric acid. So that we will get accurate volume reading. tengok dah tak ada dah air bubble kat bawah tu. And then we record the initial reading. Okay, tak semestinya awak letak sampai kosong tak kisah pun, asalkan awak record the initial reading. Kemudian awak drip slowly. Kemudian kita stop as soon as the colour jadi colourless. Nah, dia buat this is swirl. Inilah swirl. Okay, dia pusing-pusingkan conical flask tu. So add sampai colourless. Tada, colourless. So what should you do? Stop. Okay, awak akan stop. Jangan tambah lagi dah. Kalau awak tambah lagi dah, dia akan jadi acidic. Okay, and then you calculate the rough volume tadi dengan final tolak initial reading. This is our final. Okay, tolak tadi, dapatlah the rough. Kemudian awak repeat balik. Okay, bubuh balik 25 cm3 of potassium hydroxide dalam conical flask. Bubuh balik indicator sebab kita nak start doing the experiment again. Awak pun pasanglah sampai macam tadi, sebab awak dah dapat record the reading tadi, awak bubuh sampai dekat-dekat nak sampai volume tadi, baru add drop by drop. Ini dia buat laju je dulu, laju kan, sampai dekat dah nak dekat dengan volume yang dia dapat tadi, baru dia buat perlahan-perlahan. Okay, nampak? Baru dia buat perlahan-perlahan. Occasionally rinse, okay. Rinse je, tambah je distill water kat tepi supaya semua nitric acid ada masuk dalam tu. Okay, kemudian awak ulanglah beberapa kali, recordlah final semua. Ya, masukkan dalam table. This one, the one yang kita tengok tadi. Dapatlah kita the volume of nitric acid needed. Okay, lepas kita dah dapat volume of nitric acid needed, then kita akan calculate to find the concentration, which we will do it in our next class. So until then, do you have any question, class?